percentage, the accumulative percentage and past percentage of the aggregate. And then about the shape. About the shape of the aggregate. How many kinds of shape? Aggregate can. How many? How many kinds of shape? 4. Yeah? Or 3? Yeah. 4. The first one is the round.
Round.
And then angular. And then flat or needle. Flat or needle. Yeah. This kind of shape is useful or harmful for the concrete. This shape, okay?
Yeah.
You can tell me this shape is useful or harmful for the concrete?
Yes.
Useful or harmful? Harmful, yes, harmful. So if we want to evaluate the quality of the aggregate, this index is very important. If this index is high, it means the quality of the shape is bad or poor. Bad or poor. And then about the surface of the aggregate. What kind of surface? What kind of surface of aggregate? Okay, smooth. Smooth. And then another kind of surface is a roughness. Yeah, roughness. So for the crushed stone or the pepper or the natural stone, maybe for the natural stone, the shape of it is round and the surface is smooth. So how about the effects for the performance of the concrete? For the workability, okay, for the workability, this one is good or bad? For the workability, okay, this shape and this surface is good or bad? For the workability, we need to mix them, transform them, and construct them. For the workability, this shape and this motion is good or bad? It's good. Yeah. But for the strength, this shape and this kind of surface is good for the strength. Okay? This was the workability. This was the strength. Okay. And then we learned something about the gradation curves and how to decide the percentage of proportion of the aggregate. Okay. Today we'll move on to another chapter. This section is about the organic bending materials. So from this topic of this section, there are 3 words. Okay? From the last one, materials. What we have learned in last months is all about materials. Yeah? I have introduced to you what is materials, what is the similarity of the materials, and we have learned one of the materials is the aggregate. So this is the aggregate. The second word is about the bending. What is the bending? What is bending? Okay? Yeah. Just like this one. Yeah. Because in concrete, there are many sand, there are many stone. They are all particles. Yeah? They are all particles. We need to use this kind of bending materials to adhere. and pair them to make them to be a whole solid and get the strength. So this is about bending. And the third word is about the inorganic. If we refer to inorganic, there is another word is about the organic. Organic. So this is the inorganic binding materials. What do we have? So what kind of materials belong to the inorganic binding materials? Maybe this is the first question we need to answer. What kind of materials belong to the inorganic binding materials? So who can tell me what kind of materials you know is the binding materials? Cement, asphalt, and then another one, any other? Steel? Oh no, steel is not a binding material. Binding materials. Reason?
Latex.
Pen? Painting. You know painting?
No. Rubber.
Maybe no. Painting is not about, it's not belong to painting.
What about rubber?
How about that gentleman? Exposing or raising?
Finishing.
Raising. Yeah, it all belongs to the binding materials. Okay. In this chapter, we need to know 4 sections. The first one, we can get the definition of the inorganic binding materials. So I can tell you what kind of materials belong to the inorganic binding materials. And then classification of this kind of materials. Because materials, we can classify into the binding materials. And the binding materials is classified into the organic and inorganic binding materials. And in the inorganic binding materials, we can divide them into different kinds of materials. This is about classification of the binding materials. And then we will study 3 kinds of inorganic binding materials. First one is the NAM, and then the gypsum. The third one is the most important one in our course. And in maybe in the future study and work, it is about the cement. So the first one, we need to get the definition about the binding material. For the binding material, is referred to any material that binds or units that separate things. What is separate things? There will be 2 kinds of separation. The first one is the particle. Yeah, just like the sand, just like the stool, it's a particle. Second one is the breaks. Yeah, they are separate. They are separate things. Separated things. The breaks. But bands or units the separated things into an integral whole. Through the physical or chemical action. So maybe we can, from this physical and chemical action or chemical reaction, we can get this kind of separate things into a whole state, whole structure. So the binding material can be divided into 2 kinds. The first one is the organic binding material. So maybe we have just said, when I ask you what is the binding material, you tell me about the cement, asphalt, and gypsum, lime. So what is belong to the organic? Maybe in this form?
Lime.
Organic. What you need to know what is organic. Yeah? What is organic?
Organic is natural.
Asphalt. Asphalt is belong to the organic binding material. But lime, gypsum, cement will belong to the second one, inorganic binding material. Inorganic binding material. Well, just that, like the asphalt, plastics, and so on, they are all belong to the organic binding materials. For the cement, gypsum, lime, and so on, they are all belong to the inorganic binding material. So, in the inorganic binding material, it can also be divided into two kinds of materials. The first one is the non-hydraulic binding material. Non-hydraulic binding material. What is non-hydraulic binding material? It means this material can harden. Harden means what? Harden means strength. Yes? Harden means strength. This kind of material can harden, keep, and develop its strength. Okay, only in the air. Only in the air means cannot in the water. So the other one is about the hydraulic binding materials. The hydraulic binding materials is it can hurt.
Lime need water. No need to what? No need water.
No. It does not mean no need water. It means it cannot develop the strength in the water. They all need the water to reaction. But if the strength need to be developed, for this one, such as the gypsum, the lime, they cannot develop its strength in the water. It can just develop the strength in the air, just like in the classroom. Yes, we use the lime, the gypsum on the wood. Yeah, it can get strength and develop its strength. But we cannot put the lime or gypsum into the water to get the strength. Okay? But for the hydraulic binding materials, it means it can harden, keep, and develop its strength, not only in the air, but also better in the water, just like the cement, So, from what we have learned, we can translate. The first one, we get the concept of the material, and then we get the binding material. Yeah? And then for the binding material, we get the organic binding material and inorganic binding material. And then from the inorganic binding material, we get these two. Hydraulic and non-hydraulic binding material. Okay, for the hydraulic, it's the cement. And for the non-hydraulic is the lime and gypsum. Okay? Did you get the relation between them? So, the first one we are introducing is about the lime. The about it is the lime really is popularly used in the civilization. The lime is one of the oldest, because maybe 2,000 years ago, we can use this kind of material for painting. So it is the oldest, one of the oldest One is the organic statements. Organic statements. Used in civil engineering for its wide raw materials, low production cost, and simple manufacturing technology. And maybe 1,000 years ago, 2,000 years ago, what we used? The land is a kind of natural material. Because at that time we have got these tools, we have got the technology to produce the land. But the land is exists in the nature. So it is a kind of natural materials to make use of. But we can use it for finding other materials. The raw materials, what we have learned about the land is just about the raw materials and production and snaking and hardening. Okay, for about the snaking and hardening, maybe there is a very interesting phenomenon for you to create. You think about the technical properties and the applications. So what is the raw materials for the land? What is the raw materials for the land? First thing we need to know what is the composition. What is the composition of the land? Who can tell me? What is the composition of the land?
Composition of land.
What is the composition of the land? I think maybe most of you maybe know about it. What is the composition of land? Calcium. Yeah. Yeah, calcium oxide. This is the composition of the land. So how can we get this substance? Maybe we need to know the raw materials. Limestone. So what is the composition of limestone? What is the composition of limestone? Yes. This is the composition of limestone. Yes. But despite this kind of materials, maybe there are some what kind of magnesium, yeah, in limestone. So for the production of the land, maybe the raw materials is the limestone. So the limestone is heated and decompounded into peatland. So for the production of the land, it to be heated to high temperature. So high temperature, the best temperature for the decomposition, for the decomposition of the limestone is 900 centigrade. And it can be decomposed into yes? It can be decomposed into calcium oxide, carbon and carbon oxide. Yeah, this is a kind of yes. It can be converted into the and for this one, the best the reaction temperature is about 700 centigrade, and it can decompose into the next one. So this is about the production of the land. Okay, maybe this is the limestone, and then we heat them, and we can get this kind of line. This kind of line. But from this reaction, where we need to pay attention to. The most important. This is the seminar for us. Yeah? This is the seminar for us. Okay? Where is the most important? Where is that reaction temperature? Is the reaction temperature.
So if it's going to be heated for the calcium carbonate, why when it's not magnesium carbonate, why is it lower than 900?
Okay, if you want to take it down.
Yeah, you said the best heating temperature is from 900 to 1000 minimum.
Yeah.
Exactly. Minimum is 900. If minimum is 900, then why?
This is the
why
one
they
line.
use 700?
This is the one I want to explain.
Okay.
Okay. Okay. What we have learned is that this is the best temperature for the decomposition of the raw materials or the limestone. Yeah.
Yeah.
But it is difficult for us to control during the production. Yeah. Because how can we get this reaction? How can we get this reaction? First thing we need to get the big size limestone, and then put them into the kiln, and then heat them. But the size of the limestone is big, yeah. And then if we decided the heating temperature is 900 centigrade. And then this is a limestone. This is limestone. And at the surface, maybe is 900. But at the core, maybe it's just 80%, 800%. So, when during the production, during the production, we always evaluate or increase the temperature to about 900 to 1100. But when the heating temperature is changed, we will get different kinds of line. We will get different kinds of. So what kind of line? Okay, we can get. The first one is according to the magnesium oxide content. Because in the limestone, it is not 100% is this one. Maybe there are 5%, 6%, or 9% is magnesium. And then we can classify them according to the magnesium oxide content. If the magnesium oxide is up to 5%, we can call it the high magnesium pigment. But if the content of the magnesium oxide is below 5%, we can call them the calcium pigment. So, according to the temperature and time of the preparation of the production, we can get different kind of line. The first one is the overburnt line. What is the overburnt line? Because if we just set the temperature is 900, okay, at the surface of the rock of the limestone, it is 900 centigrade. But at the core, it's below 900. Yeah? So we always get the temperature 100%. But if we set this one, maybe at the core is about 900, but at the surface maybe it's 1000. This temperature is bigger than the 900. So this is the way we can get over burnt. And then it means the temperature if the temperature bigger than 900, we can get that overburnt limestone. If the temperature is 900 centigrade, we can get what do we get? Good night. But if the temperature is below 900, we will get underburn. So what is the difference between these three kinds of lime? For the overburnt lime, if the temperature is higher, yeah, bigger than 900, if the temperature is higher, or the burn time is long, or the time is long, the clay will melt. The clay will melt, and the filled water wells, filled water wells the surface of lime. So, because during the heating of the limestone, it can be decomposed into the calcium oxide. This is a particle of calcium oxide. But if the temperature is higher than 900, or the time is longer, the particle will be wrapped by the melted clay. Will be wrapped by the melted clay. And then it will get the high solidity, acid, and the lime snakes slowly. So snakes would mean what? Snakes means the reaction of the lime and the water. So if we put the water into the lime powder, it will act like this. And then for the underburnt lime, it means if the temperature is below 900, or the burn time is shorter, and it does not entirely decompose. It does not entirely decompose, and the productivity is low. So maybe for the underburnt lime, maybe there are two kinds of substance in it. The first one is lime. Some of the substance is lime. The second one is it cannot be decomposed entirely. Well, for this one is free calcium oxide. This is calcium oxide. For this one, it is the best. And for this one, because there are some impurities, this is impurities in the lime. So that bending strength of this kind of line is limited. And for this one, for this overburnt line, it is harmful. It is harmful for the application of the line. Why? Because when we use the line for the construction, it always react with the water. So this reaction will happen. For the good line, this reaction is very heating. Yes. For the good line, for the high quality line, this reaction is very quick. This reaction is very quick. And for the overburnt line, what is overburnt line? We have just showed you. This is a particle of calcium oxide. The overburnt line means at the surface of the calcium oxide, it erupts by the melt plate. So this is the melt plate. So for the overburnt line, it is difficult to contact with what? It is difficult for it to contact with water. So this reaction will happen slowly. This reaction will be conducted very, very slowly. But for the good line, or for the high quality line, this reaction is very fast. Yes, this reaction is very fast. So when we put this kind of line on the wall, the good line will reaction maybe just in several hours. But the overburnt line will get this reaction maybe 1 week later or 10 days later. So it is harmful. This is why it is harmful for the limestone, for the land. For the snaking of the big line, maybe something like this. The snake line is called the snake line or the hydrated line. And during this reaction, maybe there are two physical phenomena we can find. What kind of phenomena we can find during this reaction? The first thing is that heating. Yeah? There are a lot of heating will occur during this reaction. Yes? And then is that volume expand. So there is large exothermal amount and quick maximum speed, and the volume increase maybe 1 to 2.5 times. This is two kinds of phenomena we can observe during this reaction. And to avoid the damage of the overburnt line, okay. This is another one. For the overburnt line and the good line. When they contact with the water, this reaction will happen. And we'll get the line, the hydrated line, or snaking line. The production of them are the same, but the speed of the reaction is different. For the good line, the speed of this reaction is fast, but for the overburnt line, the reaction of this is slowly. So it is this kind of line is damaged or harmful. So how to avoid the damage or the harmfulness or harmfulness of this kind of land? To avoid the damage of the urban land, they should be about 2 weeks for land to continue to have it, which is required as sneaking. So if we want to avoid the damage of the urban land, we need to get the snaking. What is snaking? What is snaking? It means put this kind of lime paste. Put this kind of lime paste for 2 weeks. 2 weeks. Why these 2 weeks? Because after 2 weeks, the reaction of the overburnt lime is slowly, but maybe 2 weeks, 2 weeks later, the oil reacts completely. It will react completely. So this is for the snaking. So about the hardening of the land. When we refer to the hardening, it always means to the stress. So it means to cover the stress of the land. The process of the hardening, maybe there are 2 kinds of hardening. The first one is the crystallization. The crystallization is about this crystal. Yes, the calcium hydroxide. And another kind of hardening is about the carbonization. The carbonization means this. Yeah. This is the crystallization. For the carbonization is will react like this. This is the carbonization of the land. Carbonization. And then how about the characteristics about these 2 different kinds of hardening? For the crystallization, the reaction will be quickening inside. Okay, when we put this lime paste onto the wall, maybe the crystallization occurs inside it. But as the surface of the lime paste, the hardening is always the carbonization. Second one, carbonization. The crystallization and from outside to inside. For the technical properties of lime, maybe the first one is the slow steady and hardening. The steady and the hardening is very slowly. And then the low strength. The low strength is when it compared with the what we will learn later. When it compared with the gypsum, when it compared with the cement, the strength of the lime is very limited. So it is the low strength of the lime. And then the good plasticity of paste. Good plasticity of the paste, we can put the paste onto the wall or onto the ground. So it has this kind of good plasticity. And then the large shrinkage of volume. So the volume change very important. So there is a large shrinkage of volume during the hardening. But during the snaking, the volume is big. But during the hardening, the volume is shrinking. So the volume stability is very poor for the man. Volume stability. And then there's a poor water resistance because it cannot be used in the water. The land cannot be used. It cannot get the strength, even develop the strength in the water for the land. And for the application, so the stability of the soil or the stability of the base is poor. And how to solve this problem? We can add the land into the soil. We can add the land into the soil and mix them and then contract them. And this land well absorb the underground water in the soil to get the higher stability of the base. So it can be used for the stabilize of the soils. Neutralize oxidized soils and then the non-cement columns used to stain soft compressive soils. So this is about the application. Yeah, you can get the PPT, okay? You cannot write it. Right?
Yeah,
All the PPT for you? For you?
You already said
Yes, you can all download it. Okay, you can all download it. You can write all of them. Okay, just write the important stuff. Okay. So maybe there are some problems we need to consider. The first one is the non-hydraulic statement. So what is the non-hydraulic statement? What is the hydraulic statement? And then analyze the crushing process of land. Analyze the crushing process of land. So discuss the reasons for the generation of underground, overflow land, and explain the harms of overflow land to concrete structures. Maybe this one is for the homework of today. Okay? The third question. I remember the third question. Maybe you can take a picture. Okay? You can take a picture. Just as the third. Okay? You can write it. You can write it. You need to discuss the reasons for the generation of the how it's produced. The underburnt land and overburnt land. And then explain the harms of overburnt. Just explain. Okay? So this one is for the homework. Okay? You need to finish it. Maybe Wednesday, can you give the homework to me? Okay, Wednesday. Yes, Wednesday. It is very good. It is very easy. That is very easy. You just write something about it. Did you get the picture? Okay.
How many pages?
How many frames?
Just one.
You just expect. You just explain it clearly. Just okay. I do not need maybe 1,000 words, maybe to the how many frames. No, it's not okay. You just explain it. Okay? Maybe several hundred words. It's okay.
You're right.
This is for the inorganic binding materials, and one of them is the land. And then we will move on to the most important inorganic binding materials. This is the cement. Yes, this is cement. And it is also the most important section for our course. Okay? So for the cement, in this section we need to know how about the introduction. I'll give you some introduction about the cement. And then what is the Portland cement? Like the Portland cement that we used all over the world. A Portland cement. And then for the cement blended with mineral admixture. And then other cement. Other cement. Because the cement Portland cement is the most important kind of cement. But there are also many other kinds of cement we can use in the civil engineering. So, for the introduction of the cement, the first thing we need to know is about the dimension of it. For the dimension of the cement, we must look this person. What did he do? He created, he invented the Portland cement. So this is a British. He is a British. Sorry, he is British. Just ask him. Let's ask him. And there is the most important, very important thing. And this year, it is subject to default. In this year, this person invented the cement. Invented the cement. So it developed in the 19th century. And it is also one of the most important building materials because we can use it for the construction of the house, for the construction of the road, for the construction of the bridge, for the dam. Yes, so it is one of the most important building materials. What this person invented the Portland cement. So why the cement is called the Portland cement?
It's from Portland.
Maybe how can we? Why the cement we call it as the Portland cement?
The name is Portland.
This kind of name is always related to the place. Yes, good. This person just ask me, find the raw materials of the cement. At where? At an island. At an island. This island is Poland. The name of the island is Poland. So the cement, we call it the Poland cement. Poland cement. And it is a complex chemical composition. Complex chemical composition. There are a lot of chemical compounds in the cement. And it is modified for high early strength, surface resistance, low heat production, or use in machinery. Okay. For the Portland cement, there are a lot of advantages of it, but there are also a lot of disadvantages for the Portland cement. For example, the Portland cement, the surface of Portland cement maybe cannot suitable for some special structures. So we need to get add something into the Portland cement to get higher strength. And then the Portland cement, the surface erosion of the Portland cement is need to be modified and the low heat production because during the reaction of the Portland cement and water, there are a lot of heatings occurs or produced, and then we need to get some low heat production. We use massive and from the color of it, maybe it's white, black, or vibrant colors. So this is about the introduction of the cement. And then I need to know, in your opinion, what is the cement? Maybe the first one you can know, you need to know. The cement is a kind of powder, yeah? It's a kind of powder, it's a kind of particle. It's a kind of powder particle. And then if it wants to be used, it must be used with water. Must be used. And then after the reaction between the cement particles and the water, the strength will be produced. And then when the time goes on, the strength will develop. It will be increased. And at the first stage, the increase of the strength is rapid. But maybe 1 month later, the increase of the strength will be slowly. Very slowly. This is about the advantages of cement. Advantages of cement. So if I don't look at this section, if I don't look there, the most useful advantage of the cement is what? What we have learned last case. What is the most useful advantage of the cement? Yes. It can develop the strength in the water. Yes, it can develop the strength of in the water. So it is a hydrolysis. And then the bonding well is the bar. What is the bar? Is a kind of steel. Yeah, it's a steel bar. Because the steel concrete is popularly used in northern structures. So the bonding is very well between the bar and the cement and the bar. And then durability, it means the lifespan of the structure. And the simple process. The simple process means it is very easy for us to construct the cement. Yeah, we can just get the raw materials of the concrete, such as the cement, the water, the fine aggregate and coarse aggregate, and then put them together. Yeah, and mix them. It is very easy for us to construct it. So the simple process. High strength. And for the high strength, because what we have read in the chapter 1, for the same material, maybe there are a lot of different kinds of strengths. Yeah, the compressive strength, the tension strength, the shearing strength. Yes, but for the cement, if it refers to the high strength, the strength always refers to what kind of strength? If I tell you the strength of the cement is very high, but we need to know the strength is refers to what kind of strength? Compressive strength. Yeah? The compressive strength of the cement is very high, but the tension strength the tension strength is very limited. So the high strength refers to the compressive strength. And the plasticity means what? When we mix the raw materials of concrete or cement, we can put them into different kind of molds, yeah, to get different kind of structure, such as the beam, such as the column, such as the wall. Yeah, so the plasticity of the cement is very good. The flow ability of the cement paste is very good. And low cost. Low cost, we need to compare with the steel, we need to compare with the asphalt. The cost of the cement is very, very cheap. And the cost of it is very cheap. And various properties. So this is about the advantages of cement. So for the general cement, the Portland cement is most important. What we will study in later class is all about the Portland cement. All about this. And besides this kind of Portland cement, there are some ordinary Portland cement. And the Portland blast surface furnace slag cement. So this is the difference as a middle. And Portland cement, Portland slag cement, composed Portland cement. What does this mean? It means this is the typical Portland cement. We call it Portland cement. But when we add some mixture, into the Portland cement, we can get the ordinary Portland cement. And when we add the slag into the Portland cement, we can get the Portland blast furnace slag cement. And when we add the fly ash as a mixture into the Portland cement, we can get the Portland fly ash cement. What is fly ash? Do you know what is fly ash? It is the byproduct of the power plant. Power plant, do you know?
Yeah.
Power plant. The power plant, when the power plant produces the electricity, it needs to burn the coal or the gas, especially the coal. And during the production, the fly ash, we can get this kind of byproduct. And this is a very useful byproduct for the cement. And then if we add 2 or more kinds of mixture into the Portland cement, we can get the composite Portland cement. So this is about the general cements. And then we are studying about something about the Portland cement. The first one is about the manufacture or the production of the Portland cement. We need to know what kind of raw materials we can use, we need to use. And then what kind of technologies we need to conduct to produce the Portland cement. And then about the cement chemistry. What is the cement chemistry? It means the reaction of the water and the cement. And then the hydration, setting, and hardening. The hydration, setting, and hardening are all related to the reaction of the cement and the water. And then the technical properties. When we produce the cement, after the production of the cement, how can we evaluate the properties of this kind of cement? We need to use this kind of technical properties. And then the chlorine of hardened cement. So for cement, for the hardened cement, there is chlorine for it. It's chlorine for it. And the characteristics of application of the Portland cement. Okay, first one we need to know is the manufacture of the Portland cement. First thing we need to know what is the raw materials for the Portland cement. The raw materials, maybe there are 3 main compounds. This is about the 3 main compounds in the cement. The first one is the lime. Calcium oxide is about 65% in the cement. So it is mostly substance. So it comes from ore. It comes from the limestone or chalk. So this is one kind of raw materials. And then second compound is the silicon. The silica is about 21% in the silica. Okay, this is in the Poland cement. What is the other kind of cement? Okay, in the Poland cement, 21%. And the silica is come from where? It comes from the clay. It's come from clay. The third one is the aluminum. Aluminum maybe just about 5%. Aluminum. It also comes from the clay. So from here, we can conclude what? There are two kinds of raw materials we need to use for the production of cement. How about the two kinds of raw materials?
Lime and silica.
The limestone and the silica. The silica comes from clay. Yeah? So the limestone and the clay is the most important raw materials for the production or for the manufacture of the cement. The limestone and clay. Limestone. Despite these two raw materials, there are also other two different materials, raw materials. But these two, the limestone and the clay, is the. So about the technologies about the production of the cement. The first one we can get the limestone. Yeah, this is one kind of raw materials. And then the clay. And then the clay. These two is very important raw materials. And then we need to get some iron ore powder. So this one, the limestone is for the compound of lime. Yeah, the limestone is for the compound of calcium oxide. Yeah, the clay is for the silica or aluminum. So it's for what? It's for the blasting of the raw materials. Because when we want to produce the cement, it needs the high temperature. It needs the high temperature. How about the temperature? The production of the cement, the most important temperature is at this temperature we can produce the cement. So for the blasting or the burning of the raw materials, we can add a little some iron ore powder into it, and bleeding them, and then grinding them into powder, grinding them into particle. And then we can get this typical clinker models. This is raw materials. These are the raw materials. And then the raw materials were heated. Maybe I just said this is the most important temperature, 1,450 centigrade. And after the heating, we will get the clinker. Clinker means the raw materials after heating. We can get this kind of clinker. Okay, the clinker is not the cement. The clinker after the heating, maybe we can get something. This is clinker, but the clinker is not the same cement. It's not the cement. We need to add two kinds of raw materials. Maybe this is raw materials. Yeah. Maybe this is raw materials. Gypsum. We must add the gypsum into the cement, into the clinker, And then maybe we can add some mixing materials, just like the mixture and mixture, add mixture into the fingers, and then grinding them, grinding. We can get the Portland cement. This is Portland cement. If the cement just consists of the vinegar and gypsum, we can get this kind of Portland cement. And if we add some mixing and materials into it, we can get the same kind of Portland cement. So this is the key. This is the key. This is a cement mill. The cement mill is work for what? This mill. This mill is working for what? For the grinding. For the grinding. For the grinding of the vinegar, gypsum, and raw materials. Maybe there are two kinds of manufacturing process. First one is the wet process. That is the wet process. It means if you add some water into the raw materials, maybe this is called the wet process. Wet process. If you did not add some water in it, okay, in the form of slurry, okay, this is one of the different kinds of process, wet process and dry process. So therefore the cement chemistry. For the cement chemistry. For the cement chemistry, if I ask you what kind of compounds in the cement, what kinds of compounds in the cement? Maybe maybe calcium oxide, silica, and then okay, these are the compounds in the cement. But this is a chemical compound. This is a chemical compound of the cement. But what we need to study here is what is about the minor compound in the cement.
Iron dioxide and aluminum plus. Minor compound?
Yes, minor compound.
Yeah.
Minor compound means this chemical compound will react with each other to get different kind of minor compound. So there are 4 kinds of minor compounds in the cement. The first one is tricalcium silicate. Tricalcium, so the name will be difficult, but you need to remember that.
Yeah, this is chemistry.
Yes, the tricalcium silicate.
Yeah.
This is the chemical formula of this minor compound. And this is the dicalcium silicate. And the third one is tricalcium aluminate. And this one is 10 calcium, aluminum ferrite. Okay. Maybe the name of this kind of compound is difficult for us to remember. Yeah, but we can look at the chemical formula of them. So for the tricalcium synthetase, how about the chemical formula? It consists of what? It consists of 3 calcium oxide and 1 zinc. Yeah?
Yes.
1 zinc. For the dicalcium synthetase, it consists of 2 calcium oxide and 1 zinc. And for the tricalcium aluminate, it consists of 3 calcium oxide, 1 aluminate. Yeah? So, we need to remember the chemical formula of them. But the most useful for us, the most important for us is where? Yes, we need to remember the abbreviation of these 4 kinds of minor compounds. Maybe this is C3S, C2S, C3A, C4AF. Okay, you must know the alphabet refers to what? Okay, C refers to not pressure. C refers to what? Calcium oxide. Yeah, not only the calcium. It refers to calcium oxide. S refers to zinc. The A refers to aluminate. The F refers to ferrite. And the number is this number. Yes? 3 calcium oxide is C3. Is C3. And so this is difficult. Yeah? Maybe this is easy, but this one is very easy for us to do. So if next time I ask you what kinds of mineral compounds in cement, you must know.
No.
To tell me. They are the C3S, C2S, C3A, C4AF. Okay. But you must know what does this mean. Yeah, what does it mean? So these are the 4 important compounds in the cement. Okay. Besides these 4 kinds of compounds, there are some other compounds, but the amount of them is very limited. But there are some harmful compounds also in the cement, also in the So we have learned the manufacture of the cement. We have learned the chemist compound of the cement, or the minor compound of the cement. And then we have to learn the hydration. The hydration means the reaction between the cement and water. Yeah. When we get this kind of cement powder, we add some water into it. When they contact together, they will react immediately. And this is about the hydration. This is about hydration. About the mechanism of the hydration. And then the way to avoid the fresh set. What is the fresh set? I always mentioned what is the fresh set. And not much gypsum. the gypsum is must added into the cement. It must be added. But the amount of the gypsum is must be appropriate. It must be optimum content of gypsum. And the cement paste and the same stool. So, okay, I'll explain to you what is the flat set, okay? So, from this table, it tells us the hydration of the cement. Because what we can learn that the cement is consists of what? Clinker. Yeah? The clinker, the gypsum, and maybe some and mixture. The mixture. And at the clinker, there are 4 compounds. Yes. C3S, C2S, C3A, C4A. So, if we want to know the hydration of the cement, it is mainly refers to the hydration of these 4 mineral compounds. Yes? There are many of this. And maybe something about the gypsum. So, you get this. The first one is the C3S. Yeah, the C3S. The C3S adds the water into it. And then the reaction like this. It gets this calcium silicate hydrate. Hold on. This one? Right. This is the this from here. This is the calcium silicate hydrate, and this is the no, this is the hydrated calcium hydroxide. Yeah, this is. So for the first compound, C3A, when it add water into it, when it add the water, it will get 2 kinds of reaction products. Yeah, 2 kinds of reaction products. So this is for the first kind of compound. Yeah, to react with water. And then it also react with water. Yeah, it also react with water. And from this line, we can find what? Compare these two. Compare these two. What do we can find? What is the same? What is the difference? Yeah. What is the same? The same thing is what? The same thing is what? The same thing is the reaction product. Yeah. The type of the reaction product is the same. There are also 2 kinds of products. But the difference lies in what? The difference for these 2 reactions. Okay, the first one maybe is the amount of the water needed. Yeah, and then the amount of the product. Yeah, but there is another important difference. For the chemical reaction,
In this first we get calcium hydroxide and
but despite the amount of the product, there is another very important difference between them. It is what? For the chemical reaction. For the chemical reaction, besides the products, there is another very important condition. It is what? It is speed. Speed, reaction speed.
The speed of the reaction.
The reaction speed is different. The reaction speed is different. So, this product is very important. Why? Because if the same statement is useful, because the statement can produce stress. Yes? So where did the stress come from? It comes from this product. Okay? This is why the statement gets the stress. Because it can produce this product. So the speed of these two is different. For C3A, the speed is very fast. Okay? It's very fast. But for the C2S, it's very slow. It's very slow. So what does this mean?
Because of amount of water.
When we add the water into the cement, it will react with the water faster. And then because we have known about the strength of the cement is developed. Yes? So at the early stage, the strength of the cement is mainly come from where? At the early stage, maybe 7 days, 1 week, or 4 weeks. At the early stage, the strength of the cement is mainly come from here. Is mainly come from the reaction of C3A. And then maybe 2 months later, 1 month later,
There is no reaction.
the strength is mainly come from C2S. Okay. This is the age of the cement or concrete. This is the strength of the cement. The development of the strength is like this curve. At the early stage, the strength of the cement is mainly come from the hydration of this one, or hydration of this amount. And at the later stage, the strength of the cement is